Good day. So for the continuation of the lesson for this week, so we now have the quadrantal triangles. But then what is a quadrantal triangle? It is a spherical triangle with at least one side equal to 90 degrees. If we are going to compare it with a right spherical triangle, remember that the right spherical triangle has an angle. Okay, it has one angle that measures 90 degrees. When we talk of quadrantal triangle, a quadrantal triangle has at least one side equal to 90 degrees. So we're talking about here of side. So to continue, if a spherical triangle A, B, and C is quadrantal, its polar triangle is A prime, B prime, C prime, which is a right spherical triangle. So what does it mean? If we do have a quadrantal triangle in which it has at least one side that measures 90 degrees, then the said quadrantal triangle has a polar triangle, which is a right spherical triangle. The solution of a triangle A prime, B prime, C prime yields the solution of the triangle A, B, C. So let me just correct this. So that is triangle A, B, C. So continuing to the next slide. Okay. So if you can still our discussion in the previous module. So we do have the what we call as polar triangle. Actually, this slide is from the previous module's PowerPoint presentation. Okay, I only put it here in this lesson. So just remember that if we do have a polar triangle and we do have a spherical triangle, okay? So just remember this six equations that you can see below. So just remember this, okay? So the first one, if we do have angle A, which is from the spherical triangle, okay, from the spherical triangle. So if we're gonna add it with the side of a polar triangle, okay, polar triangle, the sum of the two is 180 degrees. So it means that the angle A of the spherical triangle and the side A of the polar are actually well, supplementary angles. So same with the angle A of the polar triangle. So its supplement is side A of the spherical triangle. So as what you can see, we do have same format for B, okay, and for C. So if we have angle B of the spherical triangle, so its supplement is side B of the polar triangle. You just remember this format, okay? So if you have a big letter, the other one is a small letter. If the other one has prime, the other one doesn't have. Okay? Next. So we have here an example. So in this example, solve the quadrantal triangle. Okay? The quadrantal triangle ABC. So as what you can see in the problem, we do have a given angle here. So the given angle is A. that measures 122 degrees and 39 minutes, and side A that measures 116 degrees and 53 minutes. But then what is this measurement here inside the parenthesis? Okay, this is the measure of side C, which is 90 degrees. Remember that a quadrantal angle, okay, it is described as a spherical triangle in which at least one side is 90 degrees. And in this problem, so we can actually um, see that the side C of the given is 90 degrees. That is just to what? That is just to make it clear that the problem is a quadrantal triangle. Okay, next. So how are we going to solve this? So let us switch to the black screen. So we do have again the given. Angle A measures 122 degrees, 39 minutes. Side A that measures 116 degrees and 53 minutes. Okay. And then remember we are asked to solve the triangle. So no need to solve for side C because you already know that side C is 90 degrees. Okay. So what do we need to solve here are of course angle B, angle C, and then side B. Okay, side B. Remember angle C, rather side C. Okay, side C is already given. That is 90 degrees. So what we only need to solve are these three. Okay, so how do we solve a quadrantal triangle? Okay, so in solving the quadrantal triangle, so we need to come up or we need to draw a circle again. Okay, so since this is quadrantal spherical triangle, so remember it has polar. It has, so it has a polar triangle. And the polar triangle, okay, the parts of it are the ones that we are going to put inside our circle. Remember that. Okay, so let us divide this into 5. Okay, we already divided the circle into 5. So remember the polar triangle, if we do have a quadrantal spherical triangle, okay, so A, B, and C. This is the name of the quadrantal spherical triangle. Its polar triangle has the primes. So remember that. So we have A prime, B prime, C prime. So it is polar triangle A prime, B prime, and C prime. So since our circle is the circle of the polar triangle, it means that all the parts of this circle will have the prime too. Okay? It will have the prime too. So let us write first the parts. So we have for example our A is here. Okay? B, and then opposite it, complement of C. And then we do have here the complement of angle A, then the complement of angle B. So double check the parts. So we have B, A, B, complement of C, then we have A here. Okay, now, since these parts are parts of the polar triangle with the primes, okay, with the prime, so it means that the parts of this circle, okay, it will have prime also, like this. Okay, so we are done with the circle now. if you can still remember, when we solve the right spherical triangle, also in derivation, so we take a look at the given and then one of the unknowns. So we locate those parts in the circle. We do encircle. Okay, but then since our given is different from the parts that we see in the circle because it already has prime, so we need to find a way how can we come up with given in which we do have primes. Okay, so what we're going to do, we're gonna make use of these two given parts. Okay, and then what we're gonna apply are the supplements. So with the supplement, so remember, so with the supplements, if we have big A, okay, if we do have big A, the supplement of the big A is the small a with prime, okay? These two are equal to 180 degrees. Okay, remember that. So big A plus small a prime. Then the other one for the small a, so if we have small a, its supplement is a big A. But then since the small a doesn't have prime, so the other one will have prime. That is equal to 180 degrees. Okay? And then after this, we can already solve for what? For the a prime, the small a prime, and then the big A prime. So let us solve. So what we need is the small a prime because the big A is given. So the small a prime can be solved. So 180 degrees minus the big A. So the big A measures 122 degrees and 39 minutes. Then use your calcu. Okay. So in using your calcu, so that is 180 minus 122, press the DMS, 39, press the DMS. So the answer in the calculator, DMS format, is 57 degrees, 21 minutes. So this is the measure of a prime, the small a prime. Okay, next. So let us use the next given here, the small a. So with small a plus big A prime equals to 180 degrees. So what we can solve is the big A prime because we have a value for the small a. So let us just substitute 180 degrees minus 116 degrees and 53 minutes. Then use your calculator. So that is 180 minus 116 degrees, 53 minutes. So the answer is 63 degrees and 7 minutes. Okay. So we already have two values. Okay, the small a prime and then the big A prime. So these two, we're already going to locate it in our circle. So we have the small a prime. Okay. Then we do have a big A prime. So big A prime. Then now, look at our unknown here. Okay. So before we can solve for our unknown, so let us take a look at our circle again. So try to solve for the other unknown parts here. So the B prime, the small c prime, and then the big B prime. Then later, after we come up with the values of these parts in prime, okay, we're gonna make use again of the supplements so that we can solve for this three, the big B, big C, and small b. Okay. And then again, let us write the values. So again, so what we have are the values of big A prime and small A prime. So the small A prime rather measures 57 degrees and 21 minutes, and then the big A prime, it measures 63 degrees and 7 minutes. Okay. So look at the circle. So let us try to solve for or determine the measure of this side B of the polar triangle. Okay, the polar spherical triangle. So the same, we need to use the Napier's rule. So determine which one is the middle part. So this is the middle. And then the two parts are adjacent. So with this, so Napier's rule number, this is number 1. Okay. So in Napier's rule number 1, we do have sine of the middle part. So the middle part is B prime equals to, since this is adjacent, so we're going to use tangent of the adjacent part. So A prime times tangent of the complement of the big A prime. Okay. Next, let us have the final. So for the final equation, so remember we need to we need to replace the CO. Okay, the CO should be replaced. So sine B prime, so just copy it because it doesn't have the CO. Then tangent A prime. So sine B prime equals to tangent A prime times. So to replace the CO, so tangent will become cotangent. So this is using the cofunction again. So cofunction, this is to remove CO. So sine, it will become cosine, vice versa. And then tangent, it will become cotangent, vice versa. Okay. So tangent will be replaced with cotangent. Then we do have the part big A prime. Okay. So what do we need in the circle is to solve for the B prime. So let us derive the formula. So derived formula. So what we're going to do is to move sine to the other side. Okay. And then cotangent, we need to use here the identity. Okay. Cotangent theta equals to 1 over tangent of theta. Okay. So let us just copy this first. So sine B prime equals to tangent A prime times to 1 over tangent of the big A prime. Then, so we have, let us make use of the same ink. So sine B prime equals to tangent of A prime over tangent of the big A prime. Okay. Then we can already move sine to the other side. So B prime equals to arc sine of the tangent of A prime over the tangent of the big A prime. Okay. After this, we can already substitute. So let us substitute now. So B prime equals, okay. Then input it in your calcu. So try to check. So be sure that you input it correctly in your calcu so that you can come up with the answer. 52 degrees, 17 minutes. Then include the seconds. 50.14. Okay, this B prime is not yet. Okay, this is not yet the answer. This is not yet the answer. So this is not yet the answer. Because remember, what we need are the parts of the quadrantal spherical triangle. And the parts of the quadrantal spherical triangle do not have primes. Okay? Do not have primes. So with our with our value here, the B prime, so it means it is the side B of the polar. So we're gonna make use of it in determining another part of the quadrantal. Okay? So I'm gonna erase. So let us erase this portion. So let us try to see what part of the spherical triangle can we have, or okay, can we have if we do have the measurement of B prime from the polar. So what we're gonna apply is of course the we need to consider its supplement. Okay? So if we do have a B prime value, so B prime, so think of its partner. So we have here a small b, so its partner is a big B. If one already has a prime, therefore the other one do not have prime. Remember that. And this is equal to 180 degrees. Okay. So since we do have a value for the big B, or rather since we do have a value for the small b prime, so we can solve for the big B. So that is 180 degrees minus the b prime. Okay? So 180 degrees minus our small b prime is 52 degrees, 17 minutes, and 50.14 seconds. Then you input this in your calcu again. So that is 180 minus the measurement of B prime. So the answer is 127 degrees, 42 minutes, and 10 seconds. Okay? Therefore, we already have an answer for the angle B of the quadrantal triangle. And you're gonna do the same, okay, with other parts to determine the measurements. Okay? So next, let us solve for the other one. So I'll just put a check here. So it means it is, it was solved already. So let us erase this. Okay. So let us solve or determine the measurement of another part of the polar. So say we would like to solve for this. Okay, for this one. So we need to use, okay, Napier's again. But then what number? So determine, so with these three parts that are encircled, so determine which one is the middle. So the middle part is this one. Then the other two are opposites. Okay. Next, if we do have opposite parts, so what we need is Napier's rule number 2, in which, so sign of the middle, so the middle is a prime, small a prime, equals to, so since we do have your opposite, so what we're going to use is the cosine, then complement of the big A prime times cosine of the complement of the small c prime. Okay, next. So we need to have the final. So the final equation. So again, so what we're gonna do, so we're gonna replace the trigonometric function, okay, once we see the CO. So copy the left side. So we have sine of small a prime. On the right side, we do have your CO. So replace cosine with sine. Copy the part that is big A prime. Then the other is CO again. So cosine will become sine. Copy the part small c prime. Okay. And then we need to derive the formula. So in deriving the formula, well, so there's no cotangent here. So we're not going to apply the trigonometric identity. Okay, no cotangent. So what do we need again is the small c prime. So since we need the small c prime, so we're going to, well, we need to leave it on one side alone. So let us rewrite. Okay, so since we need the c prime only, so let us divide both sides by sine of the big A prime because we need to transfer it to the other side. So dividing, so we can cancel this. So what we have now is sine of the small a prime over sine of the big A prime equals to the sine of small c prime. This can also be written, okay, as sine of c prime equals to sine of the small a prime over sine of the big A prime. And again, what we need is the small c prime. So it means what we are going to do. So we have to move sine to the other side. Okay. So we have small c prime equals to arcsine of small a prime over sine of big A prime. Okay. Next. So we can already substitute. Then input this in your calcu. So the answer is 70 degrees, 44 minutes, and 4.92 seconds. Again, this is not yet the answer because it has prime. So not yet the answer because it has prime. So we're gonna use it to determine one part of the quadrantal. Okay. So let us erase this portion. Okay, so let us take a look at this. So we do have C prime. So since we do have C prime, okay, a value for C prime. So think of its supplement. Okay, so if we have a small c, automatic its supplement is a big C. Since our since the one with a value or with a measurement already has prime, so the big C won't have prime. Then this is equal to 180 degrees. Okay, so what we can solve here is the big C. So 180 degrees minus the small c prime. So 180 degrees minus what is our small c prime? So 70 degrees, 44 minutes and 4.92 seconds. So use your calculator. So the answer is 109 degrees, 15 minutes, and that is 55.08. So that is 55 seconds. Okay. So this is another part of the quadrantal triangle. Okay, so let us delete this. So since we already solved for this part, so the one left is this. Okay. So using Napier's rule again. So looking at our circle, so as what you can see, so this time the middle is the CO, okay, complement of the big A prime. Then these two are opposites. Since we do have opposites, so what we are going to use is the Napier's rule number 2. So in Napier's rule number 2, so sine of the middle part, so complement of the big A prime equals to, so since we do have opposite, so we do have cosine small a prime times cosine of the complement of the big B prime. Okay, next. So let us have the final equation or final formula. Okay. So with this, we need to replace those with CO. So replace the trigonometric function. So for sine complement of the big E prime, so since it has the CO or complement, so sine will become cosine, then copy the part, so that is big A prime, equals to cosine of the small a prime. Then cosine of the complement of big B prime, so it will become sine of big B prime. Okay? So let us now derive the formula. So what we need is this one, the big B prime. So it is here. Okay. So let us divide both sides. So just copy. So we need to write the big B prime alone on one side. So we're going to divide both sides by cosine of the small a prime so that we can move the cosine of small a prime to the other side. Okay, so we can cancel this. So what we have is the cosine of the big A prime over cosine of the small a prime equals to the sine of the big B prime. This can also be written as the sine of the big B prime equals to cosine of the big A prime over cosine of the small a prime. And then now, as what you can see, so since we already have big B prime here, so we need to move sine to the other side by applying inverse trigonometric function. So we do have big B prime equals to arc sine, then copy the right side, cosine of big A prime over cosine of small a prime. Then just substitute. So we have cosine Our big A is 63 degrees and 7 minutes. And then our small a is 57 degrees and 21 minutes. So the measure of our big B prime, so let us input it in our calcu. So arc sine of cosine 63 degrees 7 minutes, cosine 57 degrees and 21 minutes. So we have 56 degrees, 56 minutes, and 34.95 seconds. Okay. So again, this is not yet the answer. Not the answer yet. Not the answer yet, or not yet the answer. Okay, so we're gonna make use of this measurement of the B prime in order to solve for one of the parts of the quadrantal triangle. So let us erase this. Okay. So since we do have a big B prime, so think of its supplement. So if we have a big B here, so its supplement is a small b. Since the big B already has prime, therefore the small b do not have. Okay, doesn't have. So this is equal to 180 degrees. Okay, so what we can solve here is the small b. So 180 minus 180 degrees minus the big B prime. So we have 180 degrees minus 56 degrees, 56 minutes, 34.95 seconds. Then just input it in your calcu. So 180 minus the small b prime. So, or 180 minus the big B prime. 180 minus the big B prime. So the answer is 123. 123 degrees, 3 minutes, and 25 seconds. Okay. And this is the measure of side B of the quadrantal triangle.